Today's video is on integration using residues. In today's video, we are going to find the poles and the residues at each pole of tan hz. See here, first of all, what is given? F of z is given as tan hz. So we have to find the poles for it. So in order to find the poles, so let's get started to find, that is f of z can be written as, this is sine hz by cos hz. So as it is an hyperbolic function, so this can be written as f of z is equal to e power z minus e power minus z by 2. And next one for cos z I am writing as e power z plus e power minus z by 2. Clear? So if I cancel these two, and f of z value will be, so f of z value will be, this is e power z minus e power minus z by, in the denominator, that is e power z plus e power, this is minus z. So here f of z value is equal to, so if I divide each and every term with e power minus z, so this is e power minus z by, this is e power minus z by, so in the denominator also with e power minus z. So in order to balance, so this is e power minus z by, this value is e power minus z. So it goes in one time, so it also goes in one time. So what remains here? So f of z value is equal to, so if I send it to the numerator, this will be e power 2z minus 1 by, this value is e power 2z, this value is plus 1. So here we got the function value. So here we got the function value, f of z is equal to e power 2z minus 1 by e power 2z plus 1. So for this function, we have to find the poles. So we have to find the pole values. So in order to find the pole values, what we have to do? So we have to equate the denominator to 0. So what is the denominator here? That is e power 2z plus 1 is equal to 0. So which can be written as, this is e power 2z minus I square is equal to 0. So this can be written as e power z square minus I square is equal to 0. As you know that I square value is minus 1. So here I square value is minus 1, and this is minus, again minus of minus plus 1. Got it? And next thing here is, so I wrote this as e power z square minus I square. So this is of the form a square minus b square, which I can write as, so which I can write this as a plus b into a minus b. So this is a plus b into a minus b. So we got this last step as e power z square minus, this is I square is equal to 0. So this is of the form a square minus b square. So this can be written as e power z plus I, and the next one, this is e power z minus I is equal to 0. So now I am going to equate each and every term to 0. So this is, if I equate e power z plus I is equal to 0, and see what happens here. This will be e power z is equal to, this is minus I. So I am going to write this as e power z is equal to, the real part here is 0 and the imaginary part I into 1. So now this can be written as, so what is 0 here? This is cos pi by 2 is 0 minus I into, what is one value? This is sine pi by 2. So for 1 I am writing sine 90, and for 0 I am writing cos 90. So this is of the form cos theta minus I sine theta. So this can be written as cis theta. So this can be written as e power, this is minus I pi by 2. So this is e power minus I theta. So theta value here is pi by 2. So as the bases are equal, I am equating the powers. That is z is equal to minus I pi by 2. Clear? So each and every step I have written here. And the next thing here is, if I equate this to 0, that is e power z minus I to 0, and this will be e power z is equal to plus I. So I am writing this as the real part as 0 and the imaginary part into 1. So again I am writing e power z is equal to, for 0 I am writing cos pi by 2, and for 1 I am writing, this is I into sin pi by 2. So this can be written as, so cos theta plus I sin theta is nothing but e power I theta. That is e power I into the theta value here is pi by 2. As The bases here are equal. I'm equating the paths, that is z is equal to I pi by 2. So now these are the pole values. So first pole value is nothing but z is equal to minus I pi by 2, and the second z value here is I pi by 2. See here, so as this is the easiest thing which you have to understand. First of all, what is given? F of z is given as tan hz. So tan hz can be written as sin hz by cos hz. As it is an hyperbolic function, I am writing in the form of exponential function as e power z minus z by 2, and this cos hz as e power z plus e power minus hz by 2. After cancelling 2, so this will be the function. So if I divide the numerator and denominator with e power minus z, so this will be the function. So in order to find the poles, we have to equate the denominator to 0. So I am writing 1 as, see here, I square is equal to 0. So e power z square minus I square is equal to 0. I square is equal to here minus 1. So this is of the form a square minus b square. So which I can write as a plus b into a minus b. So a square minus b square can be written as a plus b into a minus b. If I equate this to 0 and z value, the pole value is minus I pi by 2. If I equate e power z minus I to 0, and the z value is I pi by 2 plus I pi by 2. Clear? And here, see, we have to find the residue values. So in order to find the residue values, so what is given here? F of z is given as, see clearly, f of z value is given as e power 2z minus 1 by e power 2z plus 1. So this is our f of z value. So f of z is equal to first one, that is e power 2z minus 1 by, this is e power 2z plus 1. So we have to consider the first function as phi of z and second function as xi of z. Clear? See, this is also very simple as it is of the form u by v rule. So this is the another kind for finding residues. So first function is that phi of z and second function is xi of z. And in order to find the residue at any point, the residue of f of z at point z is equal to z naught. See here, the formula is we have to leave the numerator as it is and we have to make a derivative for the denominator, and again we have to substitute the point z is equal to z naught, and that is the formula. So here the first thing here is, the first pole here is minus I pi by 2, and now I am substituting the same thing here, residue of, so here residue of f of z at point z is equal to minus I pi by 2. Here z naught value is minus I pi by 2. So phi of z, so what is our phi of z value? Phi of z value is nothing but e power 2z minus 1, and psi of z, we have to make a derivative for the denominator. For e power 2z, it is e power 2z, and again z1, so we have to keep 2 here, and here the point here is z is equal to minus I pi by 2. Wherever I find z, I am going to substitute as minus e power I pi by 2. That is 2 times of minus I pi by 2 minus 1 by, here 2 times of 2 into, that is minus I, this is pi by 2. Clear? Now I can cancel this 2. After cancelling this 2, see, this value, I can write this as e power minus I pi minus 1 by 2 times of e power minus I pi. Clear? So this is the residue value of f of z at point z is equal to minus I pi by 2. And now, see, this can be written as e power minus I pi is nothing but cos pi minus I sin pi. I sin pi minus 1 by 2 times of, this is cos pi minus, this is I sin pi. So what is cos pi value? So here cos pi value is nothing but, see I am writing cos pi value is nothing but minus 1 and sin pi value is nothing but 0. If I substitute these values here, cos pi value is nothing but minus 1, minus this is 0, minus 1 by 2 times of, this value is minus 1, minus 0. So, which is equal to minus 2 pi minus 2. The value here is plus 1. So here the value here is plus 1. So this is nothing but residue of f of z at point z is equal to minus I pi by 2. So at the pole value z is equal to minus I pi by 2, our residue value here is 1. And the next value is also we have to find. So again we have f of z is equal to f of z value is equal to e power 2z minus 1 by e power 2z plus 1. So this is e power 2z minus 1 by e power 2z plus 1. Now I have to find the residue value. In order to find the residue value, I have said that residue at the point f of z at the pole value I pi by 2 is equal to, the first one we have to make the derivative. So that is phi of z by z dash of z at point z is equal to z naught. So first one numerator I am writing as it is, that is e power 2z minus 1, and second denominator we have to make a derivative, that is 2 into e power 2z at point z is equal to, this is plus I pi by 2. And now if I substitute this one, this will be 2 times of 2 into, this is I pi by 2 minus 1 by 2 times of e power 2 into, this is I pi by 2. So now if I cancel this 2 and see, this will be e power I pi minus 1 by, this is 2 into e power I pi. So here I pi cos e pi is nothing but cos pi plus this is I sin pi. This is minus 1 by, this is 2 times of e power I pi is nothing but this is cos pi plus this is I sin pi, as cos pi value is equal to, so what is our cos pi value? Cos pi value is nothing but minus 1 and sin pi value is equal to 0. So if I substitute these values here, then cos pi value is equal to, so cos pi value is equal to minus 1, and this value sin pi 0, this is again minus 1 by 2 times of, again cos pi value is minus 1 and this value is 0, so which is equal to, so here this is equal to minus 2 by, this is minus 2. So we got the value of the residue value here is, so therefore the residue of f of z at the pole value z is equal to I pi by 2 value here is 1. So this is how we have to solve. So this is the pole value z is equal to I pi by 2 and this is the residue value, and this is how we have to solve. So let me explain you once again. Here f of z value is equal to tan hz. So this can be written as sine by cos. So in the exponential form e power z minus e power minus z by e power z minus e power z, after cancelling and after dividing we got f of z value as this one. So in order to find the pole values, we have to equate the denominator to 0, as this is a square minus b square, and this can be written as this is a square minus b square, so a plus b into a minus b. If I equate this term to 0, so this is the value, that is e power minus I pi by 2. If I equate this value to 0, and this is our pole value, and second pole value is also done. And here, in order to find the pole values, f of z is equal to e power 2z minus 1 by e power 2z plus 1. First of all, we have to take the numerator as phi of z, and the next one is xi of z. The residue value, the residue values at the point z is equal to z naught is, the numerator we have to leave, the denominator we have to make a derivative, and we have to substitute the pole value here. So numerator is as it is, e power 2z minus 1 I have wrote, and next one the denominator I made a derivative and substituted z value as minus e power minus I pi by 2. So if I cancel this one and substitute the value, see this is our pole value. See, this is a pole value, that is e power minus I pi minus 1 by 2 into e power minus I pi. So cos pi is minus 1, sin pi is 0. And this is the residue value is equal to 1 at pole value minus I pi by 2. And the next thing here is the function is this one. So first we have to leave the numerator and we have to make the derivative for the denominator and substitute the pole value as it is. I left the numerator as it is and made a derivative for the denominator and substituted this one. So after substituting this one, cos pi minus I pi, I sin pi minus 1, and here cos pi value is minus 1 and sin pi value is 0. And after substituting all these values, this is the second residue value for the pole I pi by 2. This is how we have to solve. This is the most important question, repeatedly asked question. Please don't miss this video. Please pass it on if you really like. Subscribe to this channel, support this channel, and please watch the playlist. There are so many videos uploaded for you. Please practice for your preparation. Thank you so much.